Today, we're exploring the comprehensive EverBits training program. This is a curriculum built from the ground up to upskill engineering teams in functional safety. It literally takes function developers from the absolute basics of data manipulation all the way through to mastering the incredibly strict requirements of the ISO 26262 standard using model-based design. Here is our roadmap through the EverBits syllabus. We're going to look at the stakes of safety, the training delivery options, foundation building in MATLAB and Simulink, advanced logic with Stateflow, and then finally, mastering ISO 26262.
Starting right off with the stakes of automotive safety and how we move beyond fragile one-out-of-one systems.
Now, what's super interesting here is the trap of homogeneous redundancy versus true heterogeneous technological diversity. Homogeneous redundancy, which is basically just adding a second sensor of the exact same build, feels safe, right? But it actually keeps a single point of failure, which is the design itself. If one channel falls to a common cause failure, its identical twin is going to follow right behind it. Heterogeneous redundancy is the real power move. By diversifying your architecture, pairing the raw analog robustness of a tough guy passive sensor with the high-speed precision of a Precision Pro active sensor, you ensure that a flaw in one won't compromise the other. So if a sudden magnetic disturbance blinds the active sensor, the passive one just keeps on working. The lesson: don't just add more components, add different components.
Moving on to how you actually get this knowledge. Let's look at EverBits training delivery options and their flexible, scalable learning formats. EverBits basically gives you two distinct routes based on what your team actually needs. On one hand, you've got a highly customized 3-day live training. This can be online or on-site for up to 10 people, and it provides practical solutions for project-specific problems. So if your team is facing a massive, immediate project roadblock, this live intensive is your tactical strike. On the other hand, we have the 24/7 self-paced video option. If you're steadily onboarding new hires throughout the year, this is incredibly scalable. It's designed for a flexible start, offers high-quality video instruction with dedicated email support, and it serves as a fantastic foundation for future coaching.
But the crucial takeaway here is that this whole curriculum is built as a strict step-by-step ladder. I mean, you can't build a safe house on a shaky foundation, right? And you absolutely cannot jump straight into functional safety without mastering the tools first. So you start with MATLAB, move to Simulink, advance to Stateflow, and then synthesize it all by applying it to ISO 26262.
Which brings us to those foundations, MATLAB and Simulink, building the absolute core of model-based design. So the very first rung on this ladder is the MATLAB self-paced course. And the best part? Zero prior programming experience needed. It covers everything from handling and plotting data in a higher-level matrix-oriented language to writing full automation scripts. You'll learn something called defensive programming, which is essentially coding with a helmet on. You're anticipating, catching, and handling runtime errors long before they have the chance to crash your system. You'll even build custom graphical user interfaces, or GUIs, so the tools you create are actually usable by the rest of your engineering team. It's all about setting up a rock-solid environment. Okay, so once you've got MATLAB down, you graduate to Simulink. This is where function development truly takes shape as you model dynamic, continuous, and discrete systems. But listen, building the models is only half the battle. Verifying them is where the real engineering happens. You'll learn to use EverCheck for rigorous static analysis. Think of it as aggressively proofreading your code's grammar and syntax before you ever hit run. Then EverTest brings in dynamic analysis, essentially taking your model for a virtual test drive to trace requirements and generate automated verification reports.
Next up, we dive into advanced logic with Stateflow, getting into the weeds with state machines and flowcharts.
In this Stateflow module, developers learn to tackle the complex interfaces and temporal logic required for actual production projects. The training walks you through highly practical examples, showing you how to start with a basic flowchart and meticulously refactor it into a structured, finite state machine. The goal? Perfectly handling tricky edge cases while maintaining the exact same functional behavior. You're going to learn how to achieve 100% structural coverage, including strict MCDC metrics. MCDC stands for Modified Condition/Decision Coverage, and it's basically a very rigorous way of mathematically proving that every single logical switch in your design has been tested independently. Literally, no stone is left unturned.
Finally, the culmination of all this, mastering the ISO 26262 standards and bringing model-based design into the realm of automotive safety.
You're going to start with a hazard analysis and risk assessment, or HARA, to really nail down how dangerous a hazard is, formally assigning it an ISO rating. Then, you'll dive into SOTIF, safety of the intended functionality. That's where you uncover the unknown unknowns, those bizarre edge case hazards you didn't even realize existed. From there, you'll generate a comprehensive safety plan and perform tool qualification to evaluate your tool's impact and error detection capabilities. The whole process just connects chronologically, so it all makes sense.
So, as we wrap up this explainer on the EverBits training curriculum, I want to leave you with a pretty hard question. Are you still trusting human lives to fragile single point of failure systems? Or are you finally ready to equip your team with the model-based design skills needed to build a resilient, fail-operational automotive future? Mastering tools like MATLAB, Simulink, and Stateflow within the strict framework of ISO 26262, it isn't just about checking boxes for regulatory compliance. It's about fundamentally preventing catastrophic failures in the real world. The standard is set, the next move is yours.